volume of cylinders. We're going to be taking notes on volume of our first shape today. Get your note packet ready. If you don't have a note packet, you're taking these notes in your learning log. Get the title, volume of cylinders. Get the learning target. I can describe a cylinder, solve problems involving volume of cylinders. I think I forgot an and there. And remember, this is a video, so you can pause and rewind at any time. All right, here we go. So what is volume? Volume is the measure of a space occupied by a solid. Volume is for 3D shapes. 3D shapes. And in volume, your units are what's called cubed. So if we're measuring something in inches, when you find that volume, the inside of that shape, it becomes inches with a little 3, inches cubed. Okay. A cylinder is going to be our focus for today. So what is a cylinder? A cylinder is a 3D figure. Oop, that should have this line here. A 3D figure with two parallel, congruent, circular bases. I actually think I can go in there and fix that. Yes, I can. There we go. A 3D figure. That's better. And you can see pictures of cylinders on this page. Real life, I like to bring in the Pringles can, soup cans, mailing tubes like poster tubes, those kind of things you would find in our classroom if you are with us and we're working with the cylinders. All right, so how do I calculate volume of a cylinder? So the formula for volume, there's one that covers all of our 3D shapes, and then we break it down for our specific shape. So volume is capital V equals capital B, which stands for the area of the base. So you see that right here. Capital B is area of the base, and that tells the number of cubic units in one layer on your base layer. And then H stands for the height, and that tells us how many layers there are. So we have to multiply by the number of layers. So we find the area of the one layer and multiply then by how many layers that we have. Now, that big B will change for each 3D shape that we do. So for a cylinder, because the big B is a circle, the base of a cylinder is a circle, we replace the big B with how we find area of a circle, which is pi times radius squared. Okay, so we do area of a circle because that's the base of a cylinder. And then we multiply that by the height of the cylinder because that's how many circle layers are then in that cylinder. Okay, so this is kind of the generic, covers all 3D shapes for volume. And this is the specific for cylinder right here. So make sure you make very close note of that. All right, so now let's do a couple examples. We will be using a calculator to help us. And for pi, we will be using 3.14. Find the volume of the cylinder, round to the nearest tenth. Make sure you are highlighting what you need to round to. Okay, and this is good rounding practice. So the cylinder to the right, I've already picked out what I know about it. I know the radius is 5 centimeters. That's shown at the top base there. And then I know the height is 8.3 centimeters. So I'm going to go to my formula. Volume equals the area of the base is pi times radius squared. And then we're going to multiply that by the height of the cylinder because that's how many layers of that circle we have. So now we're going to substitute in. Remember, for pi, I said we're going to use 3.14. Our radius is 5, so we're going to do 5 squared, and our height is 8.3. I went to parentheses for the multiplication because with decimals, the dots can get kind of confusing. That says 5 squared. All right, I'm going to do one more piece of math without my calculator. I know that 5 squared is 25. So I'm going to change that to 25. And then I'm going to go to my calculator and do 3.14 times 25 times 8.3. And I get volume is equal to 651 and 55 hundredths. But remember, my problem said round to the nearest tenth. So because it's a 5 after the tenths place, my volume becomes 651 and 6/10 centimeters cubed. Let's try another. All right, find the volume of a cylinder with a diameter of 16 inches and a height of 20 inches. And again, we're going to round to the nearest tenth. There's no picture here. So I'm going to draw and show you how to draw a cylinder. You start with those circle bases. They kind of look more oval when you draw them. Draw one up high, one down low, and then you just draw a straight line to connect them. There's a cylinder. Now let's draw on the parts that we know. It says a diameter of 16 inches. So that goes all the way across. And we'll just put that there. And then a height of 20 inches. So I'll label that like so. Okay, so you might have to do some drawing in your practice. You'll notice on the side I already have what I know. I know the diameter is 16. But unfortunately, diameter is not part of my formula. If you look at my formula for volume, it's pi times radius squared times height. So I have to go back to knowing my circles, and that radius is half of the diameter. So 16 divided by 2 would be 8. So I'm actually going to be using 8 in my formula with my height, which is 20. So let's substitute those things in along with 3.14 for pi. So my radius is 8 squared and my height is 20. I should know my square numbers. Then 8 squared is 64. 8 times 8 is 64. And now I'm ready to substitute into my calculator. And what I get is 4,019 and 2/10. And then my units are inches. And remember, I'm cubing those units because it's area of a base. So that's square units. And then height adds a third unit. 3D shapes, units to the third. Okay. All right, last one. How do I calculate a missing dimension? So this is going to be a little bit different when I know volume of a cylinder. All right, so let's read this problem. Find the height of the cylinder if the volume of the cylinder is 56 5/10 centimeters cubed and the diameter is 1 5/10 centimeters, round to the nearest tenth. Okay, so let's start with what I know, and I'm going to draw this onto the picture here. I know the diameter, so that goes all the way across, and that is 1.5 centimeters, right? Okay, so I know the diameter is 1.5 centimeters. So the radius is 1.5 divided by 2, which is 1.5 divided by 2 is going to be 75 hundredths centimeters. And you could use your calculator to get that, okay? Now, we are looking for the height. So if we go to our picture, height is our question mark. But we do know something else here. We do know our volume. So let me duplicate this here. I know my volume. They told us the volume. So I'm going to type in here, I know the volume is 56 and 5/10 centimeters cubed, right? Okay. So I've labeled my knowns and I've written my knowns. Now I'm going to write my formula. Volume for a cylinder is pi times radius squared times height, right? All right, so we're going to substitute in what we know. We know the volume. So this goes for V. So 56 and 5/10 goes where V is, okay? We know pi. Pi is 3.14. We know our radius. We were able to calculate that. That was 75 hundredths. We're going to have to square it. We don't know the height, so we leave that as h, okay? This is going to start to look like some of our equation work from earlier in the year, where we just solve for the variable, whether it's on the left or the right. All right, so 75 hundredths squared, I have that already done. And it is, we're not going to do any rounding till the end. So this goes to 5,625 10,000ths. And then we're going to multiply pi times that, which is 1 and 76,625 10,000ths times h. Run out of room here. And then to solve for h, we have to divide both sides by that long decimal, 625h. So we're going to divide both sides by 1.76625. 1.76625. Remember, save your rounding for the very end, okay? And then we'll get 1h, our height, to be equal to 31.98. And we're supposed to round to the nearest tenth. So that 8 would make that 9 a group of 10. So our height is approximately 32 centimeters. And because it's height, we're not doing centimeters cubed. We were looking for one of the dimensions. Those are going to be our level 3 problems that we will tackle in our practice. All right, bring these notes and let's go.